Let's solve this hypothesis testing question using Rguroo. A microprocessor designer has developed a new fabrication process, which he believes will increase the usable life of a chip. Currently, the usable life is 16,000 hours, with a standard deviation of 2,500 hours. Test the hypothesis that the process increases the usable life of a chip at the zero point zero 0.01 level. A random sample of 1,000 microprocessors are tested, and they have a sample mean of 16,200 hours. Assume the standard deviation of the life of the new chips will be equal to the standard deviation of the current chips. Okay, there's a lot to digest here. As I read over this question, the feeling I got about it was that we're working with a quantitative variable, and that is the life of the chip. And I can see that with the unit of hours and things like that. So we're definitely testing a mean, as well as I see that we were only given one sample. So we're going to do a test hypothesis for one mean. So I'm going to set up my hypothesis statements, my null, and my alternative. So my mean here, my population mean is going to be equal to the 16,000 that they told us initially. That's what they know about the life of these chips. It also says it wants us to test that the process increases. Their fabrication process is going to increase that. So that helps me understand that we'll have 16,000 here and the mean, but it lets me know that this is going to be, when it increases the usable life, it'll be greater than. So we have one of the most important steps here, which is writing out the hypothesis statements. I would like to write a few things down that I'll need to use. They also said that there was a sample mean of 16,200 hours. And they said that we can assume what they know about the chips in general, which I'm thinking is a population mean, is going to be the same for our samples. So that's sigma equals 2,500 hours. And how many chips did they use, or microprocessors? 1,000. So we also have our sample size there. And finally, they want us to use a significance level of 0.01. So we have quite a bit going on there. And I'd like to get this into Rguroo and get things like a test statistic, a p-value, the probability, and so forth. So let's head on over. All right, so when we get here, we're going to open up the Analytics tab here, and we're going to click on the drop-down menu. We're going to go to Mean Inference, since we're testing a mean, and one population. Let's see. We're not pulling in a data set or anything, so we can leave that blank, but we can let Rguroo know that 16,200 was the given sample mean when they did their data. And we're using the population standard deviation, and there was 1,000. So you can see I'm giving Rguroo the things we wrote down from the text of the problem. Let's give it a let's give the variable a name. And this is basically just so the output looks a little easier to understand. So they want us to call, and we're talking about usable life here. And confidence interval is the tab that's presently showing. We're going to have to click on the hypothesis tab to open that up. And we give the significance level, which was that Greek symbol alpha, 0.01. Our alternative hypothesis was that the mean was greater than, and then here is where we put in that population mean, 16,000. So we're going to test and see if this has significantly increased. Now, in addition, we have to tell it the method to use. Since we have the population standard deviation was provided, we have a really large sample here. Seems like the great situation for using the Z statistic so that we can test this out. So let's hit preview. Quite a bit. It'll repeat back to you the things you entered, which is so great to make sure you didn't have any typos. Let's get down to here. Here's our sample mean. There's our test statistic, 2.53. Now, to remember that and write that down in a minute on our next screen. And our p-value, 0.0057. So, and before I pop back over to where I write, I'd like to look at the output. I love the graphs provided by Rguroo. And so we have them here. And I can see here that it's a right tilt test because of the greater than in our alternative. You can see that there is a little bit of shading over here. And our test statistic was 2.53, so you can see right there between 2 and 3. It also corresponds and lines up with the graph on the left, which was, that came about because of the 16,200 that was the observed sample mean. So you can see those line up. And the little red region, as small as it may be, you can see up here on the grid, is the p-value. So it being so far away from the mean of 1600, testing to a right tilt test, we can see that's a really tiny probability value, otherwise known as p-value. So let's go back. I don't have much room to write here. Let's go to another page. And I will put in, actually I'm going to rewrite the null and alternative since I kind of lost that by switching pages. The mean is greater than 16,000. And our test statistic was Z equals 2.53. So we can see over 2 standard errors away from the hypothesized mean, and our probability value is equal to 0.0057. So really small. That's not surprising. A large Z like that should be accompanied by a really small probability value. And of course, that's p-value for short. Same thing, probability value, p-value. So now we need to make a decision. And typically how these decisions go is that I like to put the p-value p-val for short, and alpha side by side. Just something I like to do. I've been doing for many years. And I have to make a decision. I mean, I'm already seeing that the 16,200 is really different and far to the right of 16,000. But we're going to look at this and we see that our p-value is much, much smaller than our significance level. Meaning that we drew sort of where unusual happens is about 1% here. And ours is well under that. So when our p-value is smaller than alpha, we reject the null hypothesis. Which means this goes away and our data is super supportive of the alternative, which says there is been an increase in the life of the processors or chips. So this is just to show you how you can get to a probability value and a Z statistic super, super, super fast using software. You don't have to use the tables or the formulas, and you can achieve these things and then make a decision for your hypothesis testing. Hope this was helpful.